Hi everyone. Today we are going to be looking at a solution to a system of equations. So a system of equations, it is really just a fancy way of saying more than two or more equations put together. So if we are graphing, make an x and y axis. Okay, if I draw two lines, if I draw one here and I draw one here. Okay, if you had to pick somewhere on that graph that was the solution to it, where would you pick? Okay, it's going to be this intersection point right here. So that intersection point looks like it's at about -1, -1. So your solution is -1, -1. Okay, so let's look at an example where we have to actually graph something. So let's try y equals -1/2 x plus 4 and y equals 3x minus 3. So go ahead, draw your x and y axis. Okay, so this first one, don't forget you always start with your y-intercept, which is this one. It's the one without the x with it. So we're going to put a point at 4. Then remember your slope is your rise over your run, so rise over run. And our slope is -1/2. So if you're rising a negative number, that means you're going to go down. So we're going to go down 1 and always go right. So we're going to go right 2. So down 1, right 2. Connect your 2 points. That was the first one. And then the second one is 3x minus 3. So we're going to start at -3. So you go down to 3, 1, 2, 3. How do I write the number 3 as a fraction? Well, that's just going to be 3/1. So we do, we rise 3 and we run 1. So 1, 2, 3, and here. And then we connect these 2 points. So let's see. Okay, and so those intersect right here. So this is our solution where they intersect. That guy right there. So we need to figure out what point that is. Well, it looks like it's at 2, 3. So your solution is at 2, 3. So now what that means is if I take, so this is your x value, and this is your y value. So if I take this x value and put it in for this equation, and I put this y value in here, we should get the right answer. So let's check our work. So you guys don't have to check your work, but I'm just showing you how it works. So if I take a 2 and I put it in for x and a 3 and put it in for y, you get 3 equals 3 times 2 minus 3. 3 times 2 is 6, and then minus 3. 6 minus 3 is 3, and that works. And then it'll work the same way as if I were to put an x and y in for this one. Okay, so your steps for finding the solution, you graph both lines and you find where they intersect. So now let's say you end up with a graph that looks like, let's say you have a graph that looks like this. What do you think the solution is for this one? So remember, the solution is where the two lines are going to intersect. But these lines appear to be parallel, which means they're never going to intersect. So all that means is you have no solution. So if your lines are parallel, you're going to have no solution. And then what if, okay, what if you have a graph that looks like this? Okay, so let's say this is my first line. And this one right here is my second line. Okay, well, they're right on top of each other. So how many times do they intersect? Well, they intersect here, 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 all along this entire line. So your solution for this one is infinite solutions. Okay, so let's do a little recap. So solutions when graphing. So you're going to have 3 different options. Okay, so the first one, okay, let's say you have 2 lines that intersect. Okay, where's your solution at? Well, it's where they intersect, so right here. And how many solutions does that have? This is one solution. Okay, your second choice is when they look like this. So these are parallel lines. So if you have parallel lines, how many solutions do you have? None. So this is no solution. Okay, and then your last one, so if that's your first line, and you graph your second line and it ends up being right on top, that is going to be infinite solutions. And that's if you graph the same line. All right, that's all I got.